Good morning, everybody, and welcome to the first virtual London and South East regional meeting. Thank you for joining us this morning. I will be running Q&A sessions for each of the presentation sessions. Normally we do the Q&A at the very end, but after each presentation we'll be doing kind of a short Q&A with each individual speaker. So if you've got any questions, please do send them in, and we'll have 5 minutes individually. And anything we don't get to, we will be addressing at the end, along with any other questions that have popped into your mind. Anything we don't get to, we will send in an email afterwards with answers from the panelists, along with a recording of the webinar so you can view it at your own pleasure. So the question box should just be on the right-hand side of your screen in a control panel. So if you just type in there, and they just come straight through to me. That is all for my introduction. So I'll pass you over to Alex and Helen to begin the proper introduction to begin the presentation. So thank you, and I shall speak soon.
Cool. Thanks, Lee. Welcome everyone to the first online London and South East regional meeting. By way of quick introduction, if you don't know me, I'm Helen Beattie. I'm hygienist for HSE's Science Division. And Alex, do you want to say hello, Alex?
Yeah, hi, I'm Alex Hills. Yeah, I'm the joint coordinator of Helen, and I work for Shell in my day job as industrial hygienist. Yeah.
Cool. So this is the rearranged London and South East welding meeting. It's with a revision to some of the speakers. This one was due to be held at SCI in London back in March, which was the week before the first lockdown, so we had to postpone it. We've got a couple of additional speakers today onto the programme that was advertised. We have Andy Gillies and Mike Perry as well, who at the end of, after Jeff and Neil's presentations, will give an update on the COMED database, which is the Control Measures Efficiency database. Our region had a workshop on this a few years ago, but the database has been updated since. So Andy and Mike are going to give a summary on it today, but we'll give a full webinar meeting on this probably in the new year, maybe March time. We are aware that this is a completely different time slot to what the London and South East members are normally used to. We normally do 5 o'clock in the evening in London. So if those members could just provide a bit of feedback. I'm assuming this time slot does work because we've got more than 100 sign-ups for the event. So we're assuming it's all right. If anyone in any regions has any ideas for any meetings, or they want to present something, then contact your regional organiser, and you can do that by email or on the communities tab on the BOHS website. Each region has their own little group set up for meetings, so just post on that page, and everyone who's signed up on that page will get an email. So just check out the communities page on your BOHS login. Before we start with this welding meeting, I'm just going to say that we do have another meeting coming up. It is another London South East regional meeting. It is on asbestos. We haven't got a date yet, but we normally have an annual event in this region for asbestos. So it's probably going to be, well, maybe in the new year, but unless we can get it in December, I'm not sure yet, but we'll let you know. Just watch out on the website for details and your emails. But I think that's all from me for now. So I'm going to pass to Alex, who's going to introduce today's session and the speakers. Thank you very much.
Thank you, Helen. Okay, well, it's my pleasure. Yeah, it's my pleasure to introduce our first speaker, who's Jeff Melton. He's the technology manager at TWI. He's also the chairman of the International Institute of Welding Commission, Commission 7, is that right? Health, Safety and the Environment.
Commission 8, actually.
Sorry, I beg your pardon. Yeah, Commission 8. Commission 8 of.
It's all in Roman. It doesn't make it so easy, does it?
Yeah, that's right. Yeah, I couldn't see the numbers. That's fine. So yeah, anyway, it's the Health, Safety and Environment Commission. So he graduated from the University of St Andrews with a degree in physics and electronics, and he's worked in welding research and development for nearly 40 years. As well as chairing the aforementioned commission, he's also the chair of the Senelec TC26 on electric welding equipment. And Jeff was the first convener of a working group set up between IEC and ISO to write a new series of international standards for arc welding, IEC 60974. This led to developing standards for electromagnetic compatibility, EMC, and the health effects of exposure to electromagnetic fields in welding. At TWI, he leads a wide portfolio of research projects from welding fume to automated welding process developments for low or zero emissions automotive applications. Jeff also has an MBA from Loughborough University and is a chartered engineer and chartered physicist. So who better than to tell us all about welding fume, how it can harm us, and what we can do about it? So I'll hand over to you now, Jeff. Thank you.
Okay, thanks, Alex. I think that, yeah, thanks for that brilliant introduction. I think it certainly got a lot of detail in there. I need to be handed over to my screen, I think. I'm not sure whether I am yet. Can people see my presentation up now on the screen?
Yeah, we've got your presentation, Jeff. So you should be able to crack on with it.
Okay, so I'll get rid of my picture so I can't see myself. Yeah, so yeah, good morning, everyone. As Alex has told you in a lot of detail, I'm involved in the welding industry. I've been involved in the welding industry for basically the whole of my working life since I graduated, and various roles, including my current role at TWI, and which is involved in research for welding and welding aspects of health and safety, and one of those happens to be welding fume. So my presentation this morning is about welding fume from my perspective in terms of the work that we're doing, and also the guidance I provide to our member companies. So I have a presentation for you today which covers a bit of the theory of welding fume, and also a bit about how we control welding fume, and you know, my comments are based on feedback we get from our member companies. So I'm hoping if I go on to the next page, which hopefully you can all see now. TWI, just a very, very short background to who we are and what we do. TWI, formerly the Welding Institute, we are headquarters in Cambridge, which is where I am, and we're a research organisation for the welding industry, and we're a membership-based organisation. So we have around about 600 members around the world. We employ around about 800 people, turnover 72 million, and we provide all forms of service to the welding industry. If there's anything to do with welding, we're involved, from the how to weld materials, how to inspect them, right through to looking at problems that may occur. If something blows up or falls down, then we have experts who can advise on what went wrong. So we cover a wide range of topics. There we go. So yeah, we've got offices around the UK, the main office in Cambridge, where we have our laboratories. We also have laboratories in Middlesbrough, Rotherham. We have an inspection and validation centre in Port Talbot, and we have an office up in Aberdeen to serve the local industry up there. So we cover everything involved in welding, from how we weld things together, how we ensure the quality of that product, and how we monitor and inspect it. And this is all based around our knowledge of materials and the properties and the performance of those materials. So anyway, the topic today is controlling exposure to welding fume, and I will go through some of the theory of welding fume generation and talk about the control methods for welding fume. There's been a lot of interest, if that's the right word, in welding fume, indeed concerns about welding fume, particularly recently following the IARC publication, monograph 118, where IARC, an international organisation, reclassified welding fume from possibly to definitely. And this is a significant change for the industry. Welding fume has many constituents, and some of those we already know are carcinogens, but this new alert widened that concern for all types of welding fume, not just the fume from stainless steels and nickel alloys, but the fume as well from mild steel processes. So as a result of the publication of the IARC, after some review by the Health and Safety Executive, there was a safety alert published for mild steel. And basically this safety alert brings the requirements to control fume in line with those requirements that we've had for many years for stainless steel. But clearly this had a lot of concern within industry, where people then needed further guidance in terms of what they should be doing, the right approach to control welding fume. Additional to that, there is a continuing reduction in exposure limits for the constituent parts of welding fume. For instance, manganese, where we saw a reduction in the workplace exposure limit in 2018, and hexavalent chrome more recently. And this continues to be the case, and throughout the world exposure limits are falling, and they're falling to very low limits. For instance, for hexavalent chrome, there are now limits in some countries as low as 1 microgram per meter cubed, which is very much on the limit of what you can measure, and very difficult to control. So from TWI's point of view, there's a lot more interest in the work that we're doing in trying to minimize exposure to welding fume, and indeed to understand where the welding fume comes from. Welding fume has a wide range of particle size. You'll see there in the graph here, right from the nanoparticles to quite large particles in welding fume. The fume is generated in the arc, and some of that vapor agglomerates to produce much larger particles. The main concern is the welder breathing in that fume and the effect on the lungs. Welding processes vary enormously in terms of how much fume they produce. From some of those processes here, which produce very low levels of fume, particularly TIG welding, which is widely used in industry for welding stainless steels, and resistance welding. We have submerged arc welding here, and for those of you that know nothing about welding, submerged arc welding isn't actually underwater, it's under a flux, a granulated flux, and the flux contains the fumes. So we get very low fume from submerged arc. But if we look at some of the other processes, particularly those that are more widely used in industry for, particularly for heavy fabrication, such as the Big Mag process, manumetal arc, and the flux core process, we produce a lot more welding fume from the process. And if we look at the hierarchy of control, what we need to do is to reduce the fume at source, particularly from these processes here, which do produce a lot of fume. We do have arc air gouging here as well, which is a cutting process, and that generates huge amounts of fume. When people had arc air gouging in the past, you could barely see it across the other side of the workshop. Of course, now that's more carefully controlled, but arc air gouging fume is also a particular concern. Welding fume is of a concern, obviously because it's a carcinogen. It also creates a lot of other diseases. I'm not a medical expert, so I won't go through all these, but it's clear that welding fume, if it's not controlled correctly, can lead to a whole variety of industrial diseases. There's also concerns from particularly manganese and the effect that that has on the brain. So we have a neurological effect here from welding fume as well, and that's believed to be due to the welders inhaling fume through the nose, and the fume from the nose then goes through into the brain. So there are lots of reasons why we need to reduce exposure to welding fume, why we should try and reduce it from the source, and implement good control measures to make sure that our welders can continue to work in a health and safety manner. So if we look at welding fume from the point of view of trying to reduce it, and a lot of my work is involved in how do we reduce welding fume at source, we need to understand how the welding fume is generated. Welding fume is generated in the welding arc, and it's due to vaporization of the metal, creates a vapor, and also spatter, which is large particles or larger particles that are emitted from the process. And these particles, the composition of this fume depends very much on the welding consumable we use. So that's the rod or the electrode, rather than the material that we're welding. And that can make a difference, because we can be welding a metal which has a limited composition, but we may want to add other elements to that composition from the consumable, such as nickel, to improve its mechanical properties. So even though we may be welding a mild steel, we may still have a consumable which has some other elements in which need to be recognized and controlled. Also, welding creates gases. I think gases are often, I won't say forgotten, but people do concentrate on the particulates, because we can see those as opposed to the gases which we can't see, but we know the process generates. And we have nitrous oxides, ozone, and carbon monoxide can be produced from the welding processes. Then we get into a bit of physics here, which is quite important actually when we try to understand the composition of welding fume. And composition is important because we need to control the individual elements in the fume. And if we look at those different elements, some of those elements transfer much more to the welding fume than others. So although we may have a welding consumable with a relatively low level of manganese, most of that manganese will appear in the fume, unfortunately. So manganese formation is much higher than we would say expect from the composition of the material we're welding, as opposed to chromium where less is transferred, so the actual percentage of chromium in that welding fume is lower. And these are important from understanding how fume is generated and how we can reduce the amount of fume and the composition from that fume. What I want to talk about is how we can reduce fume at source. So before we move on to control methods such as LEV and RPE, what can we do from the welding process which will reduce the fume? A, from the point of view of how can we develop new technologies for reducing fume, and secondly, to understand how we can use these technologies in manufacturing also to produce lower levels of fume. And as the limits come down for fume, as WLs are reduced, it becomes more and more important that we can actually reduce the amount of fume that is produced at source. So one way we can do that is by the choice of the equipment we use. We could use a welding power source, and depending on how we control the welding process, we can substantially reduce the amount of welding fume. And this graph here shows that we can have a halving of the amount of fume produced under certain circumstances, depending on the way we use that equipment. Of course, what's primarily important is that we make a good high quality weld. So some of these techniques may have a limited application, but nevertheless, they should be considered. Another aspect of this is the process choice affects how much hexavalent chromium is in the welding fume. And this slide here shows that depending on the process we use, we get more or less hexavalent chromium in the fume. Now, as I mentioned already, that the limits for hexavalent chromium are very low and are coming down again. So we need to understand better how hexavalent chromium is produced, and in that way understand how we can further reduce the amount of hexavalent chromium in the welding fume. There are some, if we use a solid wire here, the hexavalent chromium is relatively low in the fume. If we use a flux cord wire, it's much higher. So from a non-welding point of view, you may ask, well, why would we want to use a process here which generates far more hexavalent chromium than this one here? Well, the reason is that the flux cord wire process has certain attributes that make it better from the point of view of making a weld. We can make welds at higher deposition rate, we can make welds in different positions, and indeed it's easier for the welder to use a flux cord wire than it's a solid wire in many applications. So we need to balance the welding process against the amount of fume produced to ensure that we can make good high quality welds while at the same time reducing the amount of fume and reducing certain compositions in that fume to the point as well. The other aspect is just the welding current we use, and generally if we're using high welding currents up here, we produce a lot more fume than if we're using a lower welding current. I think the important thing what I'm trying to say here is that welding fume varies depending on the process we use and the welding parameters that we use. So it is actually quite complicated in terms of how much fume is produced from a given process. It varies on so many things. One of the other things that affect welding fume, and here I talk about ozone, is the voltage, and this is the welder technique. So some welders will run a long arc length, which gives you a high voltage, and that will produce a lot more ozone than welders using a lower voltage and a shorter arc length. So even using the same welding parameters, different welders will produce a different amount of fume. In this case, ozone, which is generated as soon as a welder starts welding, and has a short-term exposure limit value. So it's very important that we can control the amount of ozone that's produced from the process. And here is another factor that affects welding fume, which is shielding gas. And this is showing these are different compositions of the shielding gas that we use in welding to protect the weld port from the air to stop it oxidizing. But as you can see there, depending on the gas we use, we can get considerably less fume if we use, say, this gas here, than if we use this gas here or this one here. Generally, these gases do improve stability in the welding process, and that in turn leads to a reduction in welding fume. But for instance, if you were welding thick materials, say 1 inch thick steel, then you would use this gas here because it gives you better penetration than this gas here, which is designed for welding much thinner materials. So again, a balance between what we require from the welding process and how much fume that we generate. As I said, TWI does a lot of work on our research into welding fume, and another aspect of our work is that we support our member companies, and particularly those companies producing welding consumables with low fume. We provide a service where we can independently test and validate their claims on welding consumables. This is an example here of some work we did for one of the welding consumable manufacturers, where they developed a product which produces significantly less hexavalent chrome in the welding consumable, down to 60%. So we have facilities in Cambridge to do those fume measurements using a fume box such as here, where we run an arc under this hood, and the fume is sucked through the hood into a filter paper, which Mark here is holding, and then we analyze that filter paper to tell us how much fume is produced and what the composition of the fume is. And this is a similar bit of equipment we use here for manual metal arc welding. So we have the processes to be able to measure the fume from a whole variety of welding processes, both in the laboratory and also, of course, on site, where we can go to our member companies and do breathing zone measurements for those companies. Welding exposure limits are continually changing. They're continually coming down, and certainly there's been a lot of activity in the last couple of years with reductions in the exposure limits for manganese, for hexavalent chromium, and also for the gases. So it's important for the welding industry to keep up with these changes as published in EH40, and one of the roles that we provide at TWI is to inform our members of these changes to the limits. And also this then leads to more research into how we can control down to these lower limits, and also advice to our member companies in terms of the control methods that they should put in place to provide control of these reduced limits. Control methods, control measures. Well, as I think all of you listening to this presentation will know, there's a hierarchy of control for welding fume. We try to reduce the amount of fume at source, and I've talked how that can be done using different equipment and different consumables. The improvements in working practice is important. Basically keep your head out of the fume, but also how we present the material to the welder so that he can weld in a position that means that he's not being overexposed to welding fume, or in a position where welding fume may accumulate due to the nature and the position of where a weld needs to be made. So moving components around to provide better access can also reduce the amount of exposure to welding fume. The next, of course, is ventilation, LEV. LEV is generally required, in fact, pretty much always required these days for control of welding fume. And providing LEV is used in the right way, then it can provide a good control of fume, reducing fume exposure by up to 80% or more in certain circumstances. The limitation of LEV is that it's relatively small hood, and it has to be moved into the right position with regard to welding to make sure that the fume is captured. And when welding a long structure, this isn't always achieved by the welder, if I can put it that way. So there are limitations in using LEV. This is where other methods of fume control, such as welding torches with extraction built in, come in. And if these two measures are still unable to control the fume adequately, then we need to look at RPE. And RPE is growing in use in the welding industry. Many companies now are using RPE as a process of choice to protect their welder, but unfortunately it doesn't protect other people in the welding environment. So I always like to stress that these other methods here, where we're controlling the fume locally, preventing the fume going into the workshop, are important from the point of view of protecting everyone in the workshop, and not just the welder who is protected by his RPE. So just to sort of finish off, to look at basically the recommendations for controlling welding fume, and this really stems in the UK from the publication of the IARC monograph back in 2017-2018, where welding fume was reclassified as a carcinogen, which led to the safety alert from the HSE, where a very short statement that was issued in February 2019, but giving clear guidance in terms of how we need to protect our welders from welding fume from all processes, and particularly now for mild steel, as these guidance has been in place for stainless steel fume for quite some time. I won't dwell on this because that has since been updated. The guidance is more clearer now since February 2019. Basically, the guidance at that time was that we should use LEV for control of welding fume in all circumstances, apart from when we're welding outside where RPE should be used. I will go on to talk a bit more about that in another slide, but basically LEV is a good method of control of welding fume, and we see here a picture of a welder here with LEV and also RPE being used on a workbench. It works quite well on a workbench, but sometimes if we're working on larger components, it can be difficult to control the fume using this method. We have a good video here that I've borrowed from one of my contacts at HSE, which shows how we can use on torch extraction, and that can be quite effective in the right circumstances. And we'll see here in this video shows a significant reduction in welding fume. It works particularly well in this position where the welder is welding downhand, so the fume extraction is over the welding arc. But when welding in different positions, that does not provide such good control as maybe the LEV or the RPE would create. Welding in confined space is a particular issue because in confined spaces we have build-up of gases. So if welding is being carried out in confined spaces or spaces where fume may be trapped, it's also important to look at the amount of fume gases generated from the process. So sources of information. Well, the HSE website is a very good source of information. It's got some excellent guidance on and recommendations on welding fume, and it's good to see that now some of the work at TWI is being referenced on the HSE website as well, and particularly information about the welding processes. WL3 was issued since the safety alert. This was issued in 2019, and this provides a bit more guidance in terms of and recommendations on controlling welding fume. And there's a table in WL3 which provides information about controlling welding fume depending on the process and the intensity of use. In general, the guidance is the same, LEV, and if that's not sufficient, then RPE should be used. But there are cases where we have very low levels of welding activity, such as in repair and maintenance, where general ventilation can be sufficient to control welding fume. And this is an important document and needs to be studied carefully to work out the correct control methods, depending on the process and the time that welding is taking place. TWI is also a good source of information. We publish a lot of information on our website, very much related to welding fume and how it's generated, control of that welding fume. There is also, of course, last but not least, the Breathe Freely website. And Neil is going to talk next about the Breathe Freely website. So I've really skipped through quite a few aspects of welding fume, hopefully giving you a good introduction about what it is and how it's produced and how we control it. So at that point, I'd like to thank you and ask for any questions. Thank you.
Excellent, thank you for that, Jeff. Yep, so if you've got any questions, we'll have 5 or so minutes now to run through anything that you might have.
Yeah, I'm just glad I could hear you then, because I just realised I've been speaking for quite some time and I didn't know if there's anyone else actually able to still hear me. I'm just glad my internet connection continued to work. It could have been a big disappointment if after all that you hadn't heard what I've said. So please, yes, if anyone's got questions, I'll be delighted.
No technical gremlins today. No, we heard you all the way through.
So far, so good. That's excellent. Thank you.
I'll just
So, do we have any questions?
Just looking now, nothing just yet.
Okay. I guess a presenter always likes to think they've actually answered all the questions in their presentation, and maybe I've just baffled everyone with science.
We do have one here. If some metal elements condense more readily than others to form fume, it raises the question that do other hazardous elements remain in the vapor phase at the welder's breathing zone, and if so, how would they be sampled?
Lee, could you just repeat that, please?
Yeah. If some metal elements condense more readily than others to form fume, it raises the question that do other hazardous elements remain in the vapor phase at the welder's breathing zone, and if so, how would they be sampled?
Okay, I think the simple answer to that one is that that if we look at welding fume, the welding fume comes from the welding consumable. There are all the elements in that consumable will to some extent end up in the fume to a higher or lesser degree. There won't be any pure vapors because the welding fume will pass through the atmosphere before it gets into the welder's breathing zone. So all the fume will be in the form of oxides. And we do need to, when we sample the welding fume, then we do a whole range of compositions of elements to ensure that we capture all those oxides which are relevant. The technique is to do a summation of all those oxides to ensure that we haven't missed anything really. So hopefully that answers the question.
Thank you. We've got two more that have just come in here. The first one, I'm concerned about the number of welders I still encounter who seem to be unaware of the hazards from welding fume, including newly trained welders. Do you have any thoughts on this?
Yes, I'm always surprised actually at the lack of knowledge. I do a lot of presentations to our members who are of course all welding companies, and there is still quite a lot of ignorance in the industry about control of welding fume. I think campaigns such as Breathe Freely are doing a great job in terms of educating the workforce, and it's something that the training schools are picking up more and more on. I think perhaps one of the concerns is that that we need to better train or make sure that the younger people coming into the industry are better informed about the hazards of welding, and that they listen to latest guidance rather than perhaps on the old hands who have not been have been welding for a long time and therefore are not perhaps are as appreciative or knowledgeable of some of the hazards in the workplace. But it's all through to education and training, and there are many initiatives such as Breathe Freely, other initiatives that we're involved in, the HSE is involved in, and the training schools all have initiatives to raise awareness of controlling welding fume.
Thank you, and we've got time for one more here, I believe. And any questions, like I say, we don't get to, we will put to the panelists at the end, so don't worry if your question doesn't get to straight away. Is one of the flowcharts that in one of the flowcharts there was a mention of training for welders on use of control measures? What are your views on compliance by welders and welding companies on fully embracing educating people on the risks? Do you feel that that was similar to the previous question?
I think I probably did cover that in the previous question, didn't I? Yeah. I actually think there's a lot more emphasis on welding fume control in the workplace. I do also recognise that the welders have to be reminded that they may be given control methods. LEV particularly, I think, is a bit of an issue because LEV has to be positioned at the right place, and many welders feel that the use of the LEV gets in the way really, or they forget to move it when they're welding long components, and they do have to be reminded about that. But I think that industry is doing a better job now in terms of making sure that welders are provided with the correct protection methods and they're being used.
Excellent, thank you very much. That's kind of our 5 minutes for the first section done. So like I said, we will hopefully get to the rest of the questions at the end there. So over to you, Alex, to introduce the next speaker.
Thanks, everyone.
Okay, well, yeah, thank you, Jeff. That was very informative, and so we might get more chance to discuss some of those aspects at the end. So our next speaker, Neil Pickering, probably needs no introduction to many of us, I expect. He's been involved with BOHS for a long time. He's a chartered occupational hygienist, chartered fellow, and also a chartered safety practitioner, so CMIOSH as well, with about 30 years experience in HS&E. For nearly 27 years at Rolls-Royce, the aerospace company, Neil progressed through to company occupational hygienist before expanding into the broader HS&E roles, ending up as global head of HS&E services. He then became group HS&E director for JCB, where he initiated a global welding fume control project before setting up, as he is now, as an independent consultant. As I said, Neil has been very much involved in BOHS in many and various roles, including as registrar for the faculty, and he's currently chairing the Breathe Freely in Manufacturing campaign, which focuses particularly on welding. So I'm pleased to hand over to Neil to hear what he's got to say on this. Thank you.
Thank you very much, Alex. Thank you for the introduction, and thank you to Jeff for a great presentation. It's great to be involved in another presentation with Jeff. We've bumped into each other on a number of occasions around welding, be it electromagnetic fields or welding fume, at my various roles. We always get some great benefit out of working with Jeff and the team. So thank you very much for your time. Okay, so welding, Breathe Freely. I'm here to talk about the Breathe Freely campaign, but also explore what we intend to do next. And I thought I'd take the opportunity of also sharing a bit of learning, a bit of activity that I did in my previous role, where we did the Global Improvement Project around welding. I thought it might be useful insights for you to work from. So here we go. Breathe Freely manufacturing, as we know, focuses on welding because of the combination of significant hazard and a wide range and number of people potentially exposed to welding fumes and gases. When we started pulling this together 3 years ago or thereabouts, we worked with the HSE and we thought we could. Their estimate, the best estimate, was there was about 190,000 workers exposed to welding fume in Great Britain. That ranges from those employed as welders and spending most of their time welding or preparing to weld, to those who do short welding for maintenance or repair tasks. Some will be welding mild steel, others will weld on stainless steel or more exotic alloys with varying toxicity of the metals involved. We'll consider a bit more about that later. Of course, there's also a number of people that aren't really welders but are involved or exposed to the welding fume, and certainly in my time at JCB we identified that supervisors, potentially forklift truck drivers, and others that spend a lot of time in a welding area are of course exposed to the welding fume as well. From, again, the data that HSE was working with when we were pulling this together, we estimated there are 152 deaths from cancer every year due to welding fume. Maybe from the more hazardous metals in the fume, or as recent scientific evidence has now shown, exposure to general welding fume. Jeff's already gone through a number of these, and again, like Jeff, I'm no medic, but there are a number of ill health conditions associated with welding at work: asthma, cancer, chronic obstructive pulmonary disease, pneumonia, effects on the nervous system and metal fume fever, reduced lung function, throat and lung irritation. So some significant short and long-term effects that can seriously impact the health of an individual while welding. So as a result of this, we launched our BOHS Breathe Freely 2 campaign for manufacturing in May of 2017 in London. Pleased to say that present at that launch from the left to right were Karen Buffton, who was the BOHS president at the time, Professor David Fishwick, the Chief Medical Officer at the Health and Safety Laboratory, Martin Temple, CBE, who's chair of HSE, and Dame Judith Hackett, chair of the EEF, which is now renamed as Make UK. There were other launch partners in addition to BOHS, the HSE and Make UK. And we were pleased to have a tripartite approach in the launch partners. So in addition to Make UK and the HSE, TUC were involved, TWI, and obviously we just had Jeff speaking, and 3 manufacturers who had significant welding activity, so Toyota, JCB, and BAE Systems. Between them, the launch partners agreed the focus, messaging, and developed the materials for the campaign. We pulled together an information hub, and I'm sure many of you have been to this information hub to take a look, maybe for construction, maybe for manufacturing. If you haven't, please do. There's a lot of information there. We're in the process of revamping the website, but the information itself is actually good, and we don't need to change a great deal. So it's well worth going to take a look. It's also something that's been deliberately designed for duty holders. So it's not, it obviously helps occupational hygienists, but it is intended to help duty holders themselves as well. So it's presented in a way that should be understandable to someone running a welding team rather than someone who needs specialist scientific understanding. On that information hub, we have a range of materials available, including the control selector tool that we'll come back to. So we've got why welders need protecting, an overview brochure, some welding guides and fact sheets, and so on. So there's plenty of information there. By the way, if anyone has any good case studies on welding, we are always on the lookout for something else. If you've got any other ideas for it as well, always on the lookout. So please do get in touch with us. You can either, well, easiest thing is probably to contact head office. Rita is involved in this, or you can get me on LinkedIn if you wish to make contact. We have here an example of a fact sheet, in this case explaining what exposure monitoring is and when it's needed. I suspect many of the people on the call, if not everybody on the call, already knows about this, but of course duty holders need to understand and to get the message across to them. And we also have a briefing for duty holders to better understand the hazards and risks as a call to action. Because really we need them to step up and start to act and to make some improvements. Jeff's already gone through a little bit on this, so I'm not going to focus too much on it, but you know, we know that there are different components to welding fume depending on the metals and the type of welding that we're actually doing. It comes from the base metal, and it also comes from welding rod or wire. Clearly there are some metals here that are of greater concern than others, but something that we need to be aware of when we're doing any assessments of exposures to that welding fume. And from the perspective of welding fume components, these are the ones that are of greatest concern. Again, Jeff's gone through some of this, so I'm not going to labour it, but it's based on the toxicity and the prevalence of welding on the specified types of material. So low alloy steel can potentially lead to chromium in the fume, chromium, hexavalent chromium, manganese, and nickel. And we've already seen the welding exposure limits. Again, I've just made sure they're here. As we know, the welds for some of these components are tight or very tight and are likely to be exceeded unless we've got effective controls implemented. Following a change to the limits in August of 2018, the weld for manganese is now as restricted as hexavalent chromium, although of course that's going to tighten further for the respirable fraction. This is particularly important for duty holders using metal inert gas on low alloy mild steel, because this often involves manganese in the welding consumable. And as we've seen in the graph that Jeff shown earlier, even though it may only form 1 or 2% in the consumable itself, manganese is more volatile and can be up to 10 times that proportion in the welding fume. And certainly at my time in JCB, that's exactly what we found. We were working with 1.5% manganese in the welding fume, but actually in the in the welding consumable, but actually in the fume, it's about 15% of the fume. Therefore, the tenfold reduction in the weld for manganese in August 2018 makes effective control of exposures much more challenging than they were previously for MIG on low alloy steels. But it's no longer just certain components of welding fume that are identified as carcinogens. I'm sure you're aware that as a result of an extensive review by the International Agency for Research on Cancer, they reclassified all welding fume to be a Category 1 known human carcinogen for lung cancer in July of 2018. They also identified some evidence of a link to kidney cancer, but were unable to form quite such a positive link as they did for lung cancer. So HSE enforcement expectations were reviewed as a result of the IORC reclassification, and HSE concluded that risks had changed so markedly that a safety alert was justified, and that was issued in February of 2019. That essentially now says that for any internal welding inside, you need LEV. That's a significant step change, particularly for MIG welding, where previously that hasn't really been the case. There's been a lot of MIG welding done without LEV in place because it was considered to be relatively benign. Clearly that is no longer the case, and extraction is now required. I'm only briefly going to consider control. Jeff's already covered in more detail in his presentation, but we're all well aware and very familiar with the hierarchy of control, from the most effective at the top to the least at the bottom. Often several controls are required from different parts of the hierarchy, and Jeff has worked through a range of approaches to consider. Clearly, if we can eliminate, we should eliminate the process. And there is a possibility of moving to an alternative joining technique, maybe glues, or maybe a different type of welding that doesn't actually require quite the same process with quite the same fume coming off. Also a possibility of process modification, so automation. So you've got a robot that's doing the welding, it can be completely enclosed and the fume can be extracted and the people are taken away from the process. Of course, local extraction, Jeff talked about on torch, that can be very useful, particularly for very large components. If you've got smaller components, actually, a bench type extraction is also a very good way of doing it. Downdraft or backdraft can be very effective. And of course, there is the elephant's trunk, which, as Jeff pointed out quite rightly, the welder tends not to move and therefore tends to be a little unreliable. Jeff talked about working practices and was there's a lot of possibilities around changing welding parameters, but also about reorganizing the workplace and reorientating the weld to make possibilities easier to extract, easier to work with. And of course, there's RPE. So to help duty holders select and specify the correct extraction system for a welding activity, a working group developed the Welding Fume Control Selector tool. We designed it to be simple and easy to use so that a duty holder can understand and act on the results. And it's also free. Of course, you may find yourselves helping that duty holder. So let's take a look at what we can get out of the selector tool. Well, first of all, an introduction to the working group, which included members from BOHS, representatives from the HSE, and is endorsed by the HSE as an effective method of selecting the right control. Starting at the back left, we have Andrew Kennedy, Mike Slater, John Saunders, Don Pocock and Adrian Hurst. And on the front row, left to right, we have Dave Marsh, Adrian Paris and Marion Malloy. And they pulled a great bit of work together in creating the welding fume control selector tool. To help duty holders, we used a 5-star rating system to show real-world effectiveness of the extraction systems recommended by the tool. The overall rating is derived from the average of the 2 scores for the fume control system and user reliability. The system rating assumes an appropriately designed system which is matched to the process, is in good working order, and is set up so it can be used correctly. The user rating is based on how much control the user has. So if the control is heavily dependent on the user, it will have a low reliability score. If it's fixed in the right position, it will have a high score. You probably already figured out that the flexible and movable outputs trunk arrangement scores poorly on the user rating because, as we know, it tends not to get moved. We've deliberately kept the tool simple while delivering useful and effective advice. Through a few questions that are easy to find the answer to, such as what type of welding or cutting is it, what type of metal is it, what size is a workpiece, and how long will the welding take, the arc time. The tool leads you through to a control solution in the form of a data sheet, which you can print off or view on the screen. The selector tool provides advice on the best available control solution for the task criteria selected by the user. It also provides links to other suitable alternative fume control solutions, as it is recognised that for one-off jobs it may not always be possible to have the optimum control solution available. And with every fume control solution, there are limitations to its use and its ability to adequately capture fume, which are addressed on each control sheet. Our intent was to develop a tool that was simple to use but not simplistic in the information it provides, so that it was useful for the duty holders. I'm pleased to say that the selector tool has been endorsed by the HSE and the duty holders are frequently directed to it by them. To help duty holders, we also provide management advice sheets from links in the control sheets with appropriate advice on a number of topics, including the design of LEV, the installation, commissioning and testing of LEV, and health surveillance. Normally, I'd go into a demo of the tool and have everything crossed as it would work on the available Wi-Fi. However, that seemed too much of a stretch for today while using the connection to also present to you all. So what I'm going to do instead is suggest that you take a look, preferably at the end of the regional meeting, but if you must have a fiddle with it now, then please go ahead once you've heard from the presenters. When you do have a go, I hope you'll all agree it's simple and easy to use while giving some useful advice. Of course, any suggestions for making it better are always welcome. We're in the middle of a review of it at the moment to do just that. So if you've got any suggestions, please do let us know. I'll give you just a moment to take a photo of that QR code if you wish to, before I move on. Okay, so what next? Having explained what we have done and who was involved, I'm going to take you through our plans for the next couple of years. So, we use roadshows to help get the message out to duty holders in 2017 and 2018. This activity was sadly curtailed by resource limitations in 2019 when other activities took precedence. But we're re-energised to deliver 4 or 5 roadshows between March and September this year. I'm sure you'll have noticed that turned out not to be exactly perfect timing, so only the first of those was delivered in Birmingham. These various roadshows were successful, but did identify some challenges. Welding is a process rather than a business in most cases, so identifying duty holders is harder. In construction, much clearer who the construction companies are. Companies using welding tend not to have the same tight tiers found between principal businesses and contractors in construction, although even in construction there are many not involved in these layers. Attendance range between good with 50+ attendees down to 1 in London with barely 20. Large businesses, British Aerospace and JCB also led events, and these work well to draw in their supplies, but even large companies have few suppliers doing a lot of welding. It became clear that duty holders are widely dispersed, and they were only scratching the surface of the 190,000 welders employed in the UK. We'd already realised that a rethink was required on getting our message to our target audience. Then COVID-19 came along and stopped the roadshows, making that rethink even more urgent. Given the resource challenges experienced in 2019, we recognised that any new approach had to be sustainable for BOHS, so we're focusing on a number of key areas. Following feedback from our colleagues in the LEV industry and following up on a planned refresh, we've initiated the review of the welding control selector tool. I'm pleased to say that some of our LEV colleagues have joined us in this review, so the working party has a wider group of stakeholders involved. As part of the update to the BOHS website, the Breathe Freely site will also be redesigned to draw in more traffic, assisted by our colleagues in TWI, who are providing some excellent input. As Chris has already explained, I've had the pleasure of working. I've had the pleasure of working with Mike Slater to update the CCHRC, the Certificate in Controlling Health Risks in Construction, training courses, which have been successfully piloted, will be launched again next year. This update has restructured that course, facilitating conversion into other areas such as manufacturing, mining and so on. And we expect to follow on the construction review with work on equivalent manufacturing courses. I'm also pleased to say that Breathe Freely has expanded globally with our colleagues in Australia and New Zealand picking up the baton. And in fact, Australia at the moment are working on some advice and guidance for people working welding outside. They did wonder whether we might want to help them with doing that, but I suggested to them that there's probably only about 3 or 4 days in a year when we would even consider working outside without some sort of enclosure, so they were much better placed to do it than we were. In a moment of serendipity, just as we were reflecting on our campaign, we were approached by BAE and TWI, who were keen to drive greater engagement and wondering how they could help us. We held exploratory discussions in March, again, sadly followed by the hiatus for the usual reason this year, until the end of the summer, when we followed up those discussions and developed an outline plan. We need further discussions to agree timing and buy-off from the BOHS board, but the cooperation so far is very promising and should deliver greater duty holder engagement. I believe the discussion was going to the HSE board this month, so we're very close to moving forward. We've aligned our strategic objectives between the 2 Breathe Freely campaigns, the delivery of which will be modified by the specifics of each campaign. We use a multi-channel communications and marketing plan to reach all key audiences. For the manufacturing campaign, that means we'll leverage TWI and consumable suppliers contacts. We'll re-engage our steering group, look to recruit new participants and volunteers to avoid reliance on just a few people, look to generate media coverage in as many ways as Rita in head office can come up with, helped by the volunteers, of course, influence decision makers when the opportunity presents itself, and motivate our stakeholders, of which we need many more, to embrace and share the campaign and spread the word. Of course, our ultimate vision is to reduce the risk of occupational lung disease. I know you're all muted, but I can still hear you all asking, but Neil, how can we help? Well, I'm glad you asked. We always welcome new ideas and anything you think will help the campaign. Any new ways of connecting with duty holders who are not currently aware that Breathe Freely exists or who have not engaged fully with it. Perhaps you can volunteer to help out in whatever way you think you can. How about new links into stakeholders, particularly those with further links into further duty holders? Or perhaps you can help champion what we're doing. LinkedIn can be a tremendous tool to do that. If you can help in any way, please contact Rita at head office or, as I said earlier, myself via LinkedIn. I said I'd go on now to a practical implementation in a global company, just for some insights into some of the challenges and the activities that we did. So just to give you a little bit of context, we had approximately 2,200 MIG welders, all on mild steel. We had 96 automated welding machines, and we had an estimated annual usage of 10,000 miles of welding wire. Yes, 10,000 miles of welding wire, or approximately 4,000 tons. In the UK, we had a patchwork of controls. We had extracted full enclosures. We had local exhaust ventilation, on-torch extraction, general ventilation, and respiratory protective equipment. Outside the UK, the awareness was lower, and hence the controls were less effective. The manganese limit was challenging for MIG on mild steel. As we've said before, 1 to 2% manganese in welding rod, but 10 to 15% in the fume itself. The varied controls meant that sometimes we relied on RPE, so we did some analysis. Of 21 personal exposure measurements that we had outside the RPE, 18 of those, 86%, exceeded the new manganese well. Previously, it had just been 10% exceeded. Without RPE, our welders would have been overexposed. Of course, that also asks the question about supervisors and other people that are working in there. And yes, there were some of those that were being significantly exposed to manganese respirable fraction. So we needed a commitment to action. We recognise this as a global significant potential health risk. We proposed and got buy-in to a global project, which was brought off at the HSNE board. We appointed a senior sponsor, an MD, to one of the businesses. We pulled together a project team and a leader, obtained external expertise to assist us, and monitor progress through our governance process. In terms of our project objectives, we look to control exposures to welding fumes and gases using the hierarchy. Reduce manganese in the welding fume. Consider alternate joining techniques, automation and reduced welding. Provide effective LEV. Supplement with good general ventilation. Consistently apply RPE where it was needed, and ensure effective maintenance in inspection of that LEV and RPE. And also deliver some additional training for our welders to make sure they understood what we were doing and why we were doing it. In terms of the activities, we did a review. So we used external occupational hygienists to review our welding processes. We wanted to give clear advice and support on good practice control. We did very limited exposure assessments at this stage. We used the Mark 1 eyeball to take a look at the welding and to decide whether a particular type of LEV was most suited to the task. In many of our cases, our components were big, so it turned out that on-torch extraction was the most effective. But we did have some cases where the on-site review was able to identify the possibility of downdraft booths or other extracted enclosures in order to do effective control. We did a little bit of exposure assessments to confirm control, but only after we'd made improvements. We didn't try and measure where we knew we'd already got a problem. We also took a look at the robot extraction systems to see how effective they were. And as you might imagine, they range from being completely effective to being entirely the opposite, and fume leaking out the sides, because the robot had been changed, maybe the dimensions had changed, maybe the weld went a little further than it did originally, and it got out of the extraction system. Once we'd done a pilot of the review on site, we rolled it out across the organisation. As I said, we really did need to employ on-torch extraction because we had large components, complicated components, and it wasn't possible to get LEV into the right places other than on-torch. So we did some on-torch extraction trials to test the new generation of weld sets, and I have to say they were a lot better than the previous generation of weld sets. We had group manufacturing involved in this, and they led on this particular aspect of it. We had 5 suppliers in the trial. The effectiveness varied, to be honest, and partly that was the way it was set up, and partly it was just the kit that they used. What we did do, though, was we gave them free rein to set their kit up, so there could be no complaints from the suppliers as to how it had been done. They set it up, we then did the tests. We tested, in addition to the fume control, where we found around 70% reduction. It does depend on the orientation, but for our particular type of welding and the orientation of welding, we got around 70% reduction, which is excellent compared to nothing at all. We tested the efficiency, of course, the ergonomics, the weight, the heat, the preference by the welders to help us come out with a solution that as many as possible would like. We piloted across one business once we'd identified the right tool and the right extraction combination. So we had 90 sets, and that was very successful. We were just ironing out the last wrinkles when COVID arrived, unfortunately, and we didn't get to quite finish that this year, but the system was working well. The most important part, as I'm sure you all recognise, is getting the welders on board with it. Okay, a very quick trot through, but thank you very much for your attention. I think, Lee, you might now be seeing if there are any questions for me.
Yep, thank you very much for that, Neil. We do have a question straight away. Give people a minute or two to type in their own. How would you do air monitoring for soluble nickel as opposed to insoluble?
A good question, and one that I would have to look up, to be perfectly honest. It's not something I've needed to do for quite some time. So if there's anyone else that's already on the presenters that feels they can chip in, they're very welcome to. But it's not one that I've needed to do. So I'm very sorry to say I can't. I'm not going to try and give an answer to it.
That's fine. We've got a number of questions coming in that I can send over afterwards. So I give you a bit more time to answer them, and we can send them back afterwards. But we do have another one in the meantime. For an employer looking to purchase an LEV system for their welding process, how will the new ALARP approach, as well as all WF is class, affect the benchmark in their specification? That makes sense.
Sorry, try again, please.
For an employer looking to purchase an LEV system for their welding process, how will the new ALARP approach affect the benchmark in their specification?
I mean, it'll certainly mean that they need to be much more mindful of the LEV design. You know, in the past, I would think that people would have gone out and just bought the off-the-shelf unit that the local supplier would have provided to them, and they'd have been happy with that if it captured some of the welding fume. I think they're going to have to be much more mindful of the design, much more mindful of how it's used, make sure the employees are properly trained in it, probably do some trials before they actually fully buy into it, potentially as well, to make sure that it's actually going to do the job, which is what we were doing with the on-torch extraction system. You know, we wanted to make sure it worked before we committed to buying 2,000 units. So I think the same would be true in this case. You need to do due diligence around the extraction you're going to bring in to make sure it's going to deliver what you need. Of course, in some cases, you can't get a perfect extraction system. I mean, that's where we found ourselves, short of extracting the whole room, which would have been 100 meters by 100 meters, and clearly not practicable. We were really left with on-torch extraction.
Can I just add, if you can hear me, to what Neil said, and totally agree. And I think that it's very much assessing how you're going to, what your welding, your welder's environment, and how you would use these different control methods. So, whereas one control method such as LEV might be very effective for one welding application for different components in different positions, then another control method might be more appropriate. So I think it's important to make that as workplace assessment more so than ever, and use that as a basis of which is the best method of control. Also, I think that with reductions in exposure limits, it's more and more important of the effectiveness of the control methods. If you have a high exposure, high WEL, then it's relatively straightforward to control to that well. But as wells come down, it becomes increasingly more difficult to control the fume to a level that you're not going to exceed the limits.
Thanks, Jeff.
Oh, thank you. We've got another one here. What are your views on tack welding control systems?
Controlling welding, tack welding systems. Are we talking? Does it say whether it's well, it's likely to be MIG or TIG or something like that? I mean, you still get fume off tack welding. You know, certainly my experience, it's a brief pulse of fume, but it's still fume and it's still welding inside. So you need to put extraction to it. And again, the conversation we've just had, you know, it needs to be the right extraction for the particular type of orientation, the size of the component, and so on. So yeah, it still needs extraction. And certainly we were putting extraction onto it because you can still get some fairly significant fume comes off a tack welding process, particularly if it's a continuous type of tack welding that's going on. If it's resistance welding, it's a little bit different.
If I may, it's quite agree with you 100%. And if the tack welding is TIG welding, and a lot of TIG welding is used for tacking, another aspect of this is the ozone generation, because ozone is produced when you first strike the arc up. So it's within the first few minutes or even the first few seconds of welding. In fact, actually, I think it's the first 15 seconds that you get the greatest concentration of ozone. So although you may be only tacking for a short period of time, if it's TIG welding, in fact, the ozone is going to be higher than if you're continuously welding, because with continuously welding, the other fume gases and particulates react with the ozone and reduce the levels. So to my mind, it is vital that you consider tack welding the same way as you do for continuous welding, even though you may think you're not welding for such a long period. Because of that complex interaction between the different fume constituents, you can actually, in some cases, exceed the amount of fume you would get if you were welding continuously.
Thanks, Jeff. And clearly you've got a lot of experience of the welding process, which you already know. That's fantastic.
And then I think we've got time for just one more that's come in here before we move on to the final part of the presentation. Should supervisors, managers wear RPE when on the shop floor?
Right, so that all comes down to how well controlled the welding fume is, doesn't it? You can't give a blanket yes or no to that, but clearly if the welding fume and the gases, as Jeff said, are well controlled and the extraction is effective, and they've also got some general ventilation, then less likely to need it. Again, depending how close they are to the welding itself. If the systems in place are poor, then at least for the interim, while improved extractions added, it may be necessary. I mean, certainly we were finding that the supervisors that were involved in the welding process areas, they were actually being exposed to significant levels of manganese. One or two were getting close to the limit. So, you know, we did give them RPE for a brief period while we got other things sorted out. It was necessary. So I think it's certainly something to consider, but you need to look at the situation and assess it like you would anything else and decide whether or not they're significantly exposed or not. My experience of supervisors, they tend to be quite close to the process. Managers tend to be in meetings all the time, so they probably don't need it, but you never know.
Excellent, thank you for that. Well, we're going to move swiftly on to Mike to wrap up. So thank you for your answers there, Neil and Jeff. So Mike, if you just want to.
Right.
Yeah, I'll introduce the last two speakers, shall I, Lee?
Yeah, okay. So Mike, you've just got control just to shake. There you go. So Alex, away to you.
Yeah, so just to finish up, we've got a double act now with Andy and Mike. They're going to talk us through the COMED project, which they've been leading, which is quite relevant to welding control. So Andy's a chartered industrial hygienist, occupational hygienist, and environmental consultant with over 40 years experience. He's now semi-retired, and he's a former president of BOHS as well. He's been involved in COMED right from the initial conception, and he's part of a peer review group, and he coordinates the COMED Volunteers Register. Mike Perry is an occupational hygiene consultant and director of his own company, and for the last 13 years he specialised in the field of pharmaceutical compound safety, providing occupational hygiene services to companies throughout Europe. He's a former BOHS examiner and has recently undertaken the role of validation team leader for the COMED project. So without further ado, I'll hand over to these gents who can talk us through COMED. Thank you.
Okay, thank you, Alex, and we're grateful to the organisers of today's meeting to adjust the programme to allow us the chance to give a quick demonstration of the COMED database. For those of you who aren't familiar with it, the COMED tool is a tool that's still under development. It's not been publicly launched yet. We're hoping to do that in the first half of next year, 2021. And as Helen mentioned at the beginning, we plan also to run a full seminar, full workshop on COMED in the springtime, maybe March, April time. So that will give a lot more detail and give a much better feel than you'll probably pick up in this very quick demonstration. I'll say a few words quickly by way of introduction now, and then I'll hand over to Mike to do the demonstration. So if we have a look at the next slide, this slide shows the vision that we have for COMED, the tool itself. The idea of COMED arose from a series of seminars and workshops that we ran back in 2015, 2016 at BOHS annual conferences and regional meetings. And as a result of those meetings, we set up a working group under the auspices of BOHS that did the initial development of the tool. And since last year, since 2019, the COMED project has been led by a team based at the Fraunhofer ITEM Institute in Hanover in Germany, supported by Mike and myself and other BOHS volunteers. The special features of this database is it's a rather unique combination of an academic institution in the sense of the Fraunhofer ITEM Institute, combined with one of the premier occupational hygiene professional bodies and learned bodies worldwide, i.e. BOHS, plus individual occupational hygienists and practitioners who are contributing in many ways to the development of the database. It's quite a unique combination in that sense. Database contains information summarizing peer-reviewed literature on control measures, and also information from work that hasn't been published, the so-called grey literature, which is derived from hygienists and other contributors. So without further ado, I'll hand over to Mike to give you a quick demonstration of what it looks like.
Thank you very much, Andy. Can you hear me all right? Am I being heard?
Yep.
Yes, I think we can, Mike.
You can hear me. Good. Just confirm. Okay. So COMED, I'll give you. I'm very aware we haven't got a lot of time, so I'll do a quick run through of how the database works from the user point of view. We've got 4 tabs at the top. The first is just covering sort of background information, user manual, and so on. This is still underdeveloped, so it's just about COMED and some links and so on. But I'm going to jump straight into the data entry open database tab. And here you will see all the data sets that are currently in the database. So we've been adding these over a period of years. So as a user, you can come in, and of course, you don't want to see all of these straight away. So we're interested in welding, so I'll select welding. The search string isn't working at the moment. That'll come later on. So if I search, now you'll see all the data sets relating to welding are now highlighted. So you can just browse through those and open them at your leisure just to browse and see the summary information of it. I'm going to go straight to this one here because I know it's Andy's. And so if I go up here and open, this is basically a summary of the information that Andy has gleaned from the study itself. So it's broken up into different sections, as you can see. The first working process section enables you to choose or see which processes are covered and so on, how long the exposure time is, the size of the piece and so on, the material, so that hazardous substance information is there as well, and any additional information. The contextual information exposure measurement, this is how the hygienist or whoever's done the collected samples for it has gone about this work. Is it a workplace a piece of work, or is it in a laboratory, or so on? So all these sort of details, and whether it's sort of personal or static sampling, this is all kind of described here. Here's Andy's information here about himself and the title of the piece. And here is a description in some detail about the engineering control measure that's been is the subject of this data set. So there's plenty of opportunity here to put in technical information, and we're trying to make this a user-friendly form, but also flexible as well, because we're mindful in the future, we're going to be covering other processes, not just welding. So down here in the results data section, this is quite critical, obviously. So Andy has done some calculations on his data, and he's come up with a general figure for the exposure with the control measure both on and off. And from that, we can glean the percentage reduction, so the efficiency. So 79 has come out of this. So the last section here is the data reliability. This is something which is goes through a couple of kind of validation stages within the process of COMED. So there's the option to have good, medium, or poor. And in that respect, so we're still working on the sort of parameters that kind of define this, but at the moment we know Andy, he's a good lad, it's going to be good, isn't it? So so that's where we are with that. So that's one way of looking at the data. I'm going to now move on to the analysis and develop a query. So again, I'm going to look for welding, and I'm going to select MIG-MAG because I know there's plenty of data there. It's an LEV system, and we're going to look at on-torch extraction. So now if I search, so it's returned 29 entries here. Okay, so now you have the option to whittle this down a little bit further. So you could select you only want to see efficiency above a certain amount or a certain data year, for example. So you can exclude the old data if you want. I'm going to go slip straight to data quality good, bearing in mind what I just said before. So if I filter that, you can see it's now highlighting those that are in the selected data. So if I go to an analysis button here, I can now see the selected data. So all these studies are now shown as a bar. So you've got a quick view of what the efficiency is. Here, this is how they're grouped in the different categories of efficiency, how many studies fall into each group, and how it compares with all the data. So down here, if I hadn't have done that selection process, this is all the data. So again, you've got the same information from there. Okay, so once you've done a bit of research, you've looked at a few different options and so on, then you can now move on to what we call the PDF report. And this is something that's quite new at the moment. It's still in development, but we've come up with a sort of scoring system, A to E. We've chosen A to E because we wanted to kind of avoid the star system that is used, as was discussed earlier, for the Breathe Freely campaign, because it's derived in a slightly different way. This side of the column here is the all data, and this is the selected data from the. So we've got this performance ladder, if you like. So A is going to be the best performance, and this now we're just looking at the sort of data. This is a statistical sort of thing. It doesn't take into account the kind of robustness of the control measure, the human factors, and so on. That is coming later on, and we'll down here we will also have a score for like the human factors and the technical factors that you might want to take into consideration if you're considering this device. So based on the data, I'll go to the selected data first. Okay, so this returned 16 results. We based it on good data quality, and here the efficiency mean of that data set puts it into category C. Okay, 84%. But because the standard deviation at the moment is above 10, it's dropped it down to D. Okay, so the idea is that this will dynamically kind of adjust for the sort of statistical considerations of the data set you pull back. In this case, all data is pretty much the same as selected data. There's not a lot of difference, so it's not showing a difference. But if you whittled this down as enough data, you might be able to prove that the data is actually more efficient than all data would suggest. And so down here, you've again on this page, you've got the same information that I showed you a few minutes ago, but along with all the references for the different papers that it has come from. Okay, so I'll close that down. The final thing to show you is what we call the CAS sheet. So I'll open this, which is a control advice sheet. These are kind of standalone advice documents based on a particular control measure for whatever it is. So I'll open this one up, and this, obviously, we were talking this morning a lot about torch extraction. Here, the idea of this page is to give a kind of an easy to use reference document which discusses all the pros and cons. We're going to engage with people, experts and so on to contribute to this so that you're aware of what you're getting into when you choose a control measure. And that might include kind of cost factors as well, but it'll certainly include sort of how, what are the pitfalls and what are the advantages of it. And again, here we've got based on the best information within the database, we've got the ladder of performance again. So you can print this off and then compare and contrast different control options. So this is the whole system is geared more towards kind of thinking about data rather than other things. So it enables you to dip in and sort of look in more depth if you want at kind of the options that are available and what information is out there. So I think that kind of wraps it up for me. I hope I've not gone on too long. Andy, shall I just pass back to you now then?
Okay, thanks, Mike. And the next slide, if you could just advance it, please.
Oops. This one. Yeah.
That's the one. Thank you. So to follow on from that great demonstration from Mike, the content and functionality of the database we're working hard on at the moment to improve it continually. We're very pleased with where we've got to, but we recognise that there's a number of improvements that we still need to work on before we launch the database publicly. We are looking to identify organisations and individuals to become supporters of COMED. That may be in a number of ways, to partner with the project leaders, to sponsor the database in its development. Organisations that do support the COMED project in that way will have premium access to the full database. There'll be an option to join the advisory boards that we'll be appointing to overview and steer the development of the project over the years ahead. Marketing and promotional opportunities in any literature associated with the COMED web tool and the literature that we have. So finally, just the next slide, please, Mike. How can you get involved? As Neil issued a call to all of us earlier on, it's a mirror call from our COMED team. We'd be very pleased to hear from any individuals or any organisations who find this project of interest to them and want to explore how they may get involved further and sign up as a supporter of COMED. We currently have over 40 BOHS members who are part of our volunteers register, who are contributing in an excellent way to the improvement of the database, and more volunteers are always very welcome. It's a very exciting project where we really see great possibilities for this tool to really contribute to reducing the exposure of people to harmful welding fumes in the future. So we hope you share our excitement, and if anybody is interested and wants more information, please contact me in the first instance. My email address is given at the bottom of the slide. Okay, thank you very much. Over to you, Lee.
Excellent. Thank you very much. Excellent demonstration. Had a couple of comments coming in saying how useful it looks, which I'll share with you afterwards. So it's great to see that. That brings us to bang on 11:30. So if you do have any questions, if we can email any of the emails that you've seen today, or to marketing@bohs.org, and they'll come straight through to me. And like I say, any of the questions we've not gotten to, there's been a couple we haven't managed to get around to, I'll be passing over this afternoon, and we'll get some answers and we'll send them back out to you, so nothing will be missed. That's thank you from me. Alex or Helen, do you have anything to add before we wrap up?
No, just thank you to all the speakers, and thank you to you, Lee, as well, for hosting and letting us do this. Thank you.
Anytime, yeah. Okay, so thank you, and yeah, look out for the webinar hopefully this afternoon, and we'll be sending emails out when the next regional webinar comes about. So thank you very much.
Thank you.